Today we're going to look at lesson 8.3, solve absolute value equations graphically. Alright, so we're on task 1 if you want to follow along. To solve one variable equation of the form f of x equals g of x by graphing, you can find the points of intersection on the graphs of the functions y equals f of x and y equals g of x. The x-coordinate of each point of intersection is the value of x for which f of x equals g of x and is therefore a solution of the original equation. The graphs of f of x equals absolute value of x minus 5 and g of x equals 3 are shown in the same coordinate plane. You can use these graphs to solve the related equation. Absolute value of x minus 5 equals 3. So you can see that they took the f of x and put it on the left, and they took the g of x and put it on the right. So when they do that, they set it up, and the intersection points, the x values of the intersections are the solution. So for, so for this equation, you can see that they intersect at 2, 3 and 8, 3. So the two x's would be 2 and 8. Alright, so it says, how is the equation absolute value of x minus 5 equal 3 related to the functions f of x equals absolute value of x minus 5 and g of x equals 3? The left side is f of x, and the right side is g of x. Alright, so it says the solutions of the absolute value of x minus 5 equals 3 are the same as the x-coordinates of the intersection points of the graph of f of x and g of x. Complete the following statement. The lesser x-coordinate of the intersection points is, alright, so the lesser of the two is 2, so 2 and 8. And the greater of the x-coordinates is 8. Alright, so it says, how can you verify that the intersection points of the graph correspond to solutions of the equation f of x equals g of x? Well, all you have to do is take the ordered pair and plug it in and check it to see if they work. So if your intersection points are 2, 3 and 8, 3, just simply plug those in. So if I put 2 in for x, 2 minus 5 is negative 3. The absolute value of negative 3 is 3. 3 equals 3. And there's my 3 there. I can do the same thing with 8. 8 minus 5 is 3. The absolute value of 3 is 3 equals 3. So all you have to do is plug in the points to see if they work. The graphs of f of x equals absolute value of x minus 5 minus 2 and g of x equals 1 are shown in the same coordinate plane. You can use the graph to solve the related equation. Same thing, they took f of x, put it on the left, and g of x and put it on the right. Now we're going to find the intersection points. So 2 and 8 are going to be our x values. All right, again, the left side is f of x, the right side is g of x. And the solutions are the same as the x-coordinates of the intersection points of the graph. All right, so again, you can look at this and you can see that this is 2, 1, and 8, 1. So 2, 8. 2 is the lesser value, and 8 is the greater value. All right, choose the best words to complete the statements describing the process used and the solutions to absolute value of x minus 5 minus 2 equals 1 and absolute value of x minus 5 equals 3. All right, so the graphs of the related function of the first equation were translations of the graph of the related function of the second equation. The equations themselves are equivalent and their solutions are the same. Alright, so you can see above, this one has a solution of 2, 8, and the one above it has a solution of 2, 8 as well. So you can see that they have just taken this, and it's just a transformation. They have just moved it to a new location. But the intersection points, 2 and 8, the x values are still the same. All right, that's all for task 1. If you have any questions, please let me know. All right, lesson 8.3, task 2. Solve absolute value inequalities graphically. Remember, inequality is less than or greater than. All right, you can solve an absolute value inequality by graphing in a way that is similar to how you have graphically solved absolute value equations. However, within an inequality, the points of intersection indicate endpoints of a possible range of solutions. Examine the graphs of f of x equals the absolute value of x minus 5 and g of x equals 3 together again. All right. It says choose the functions and variables to complete the explanation of how you can use the graph to solve absolute value of x minus 5 greater than 3. All right, so the points on the graph of f of x are above the graph of g of x, represents solutions of the inequality. So the points of the graph that are above this graph, so the points that are above this graph represent solutions of the inequality. All right, the x values of those points are the solutions to the inequality. Those are the endpoints there. All right. Choose the words to correctly complete the statements. The x-coordinates of the points of intersection are not included in the solutions. This is represented by the graph by open circles. And the reason these x-coordinates are not included, remember, if this is greater than or less than, these are open circles and the endpoints are not included. If this is greater than or equal to, if it had the dash underneath it, that means greater than or equal to, then it would be included and a closed circle. All right, it says choose the words to correctly complete the statements. The portion of the graph of f represents the points where f of x is greater than g of x. Okay, so let's go back to the graph. Okay? All right, so the points, the line here where it's solid, and here you can see where it's dashed. So f of x is greater than g of x when it is a solid line. All right, the portion of the graph that is dashed represents f of x less than g of x. All right, and again, you can see the dashed line here is below, so that is less than g of x. Above is greater than, below is less than. All right, examine the graph of f of x equals the absolute value of x minus 3 plus 1 and g of x equals 5 shown here. All right, so you can see the two endpoints or the intersection points. So you've got x equals -1 and 7. And it says what is the solution set for absolute value of x minus 3 plus 1 less than or equal to 5. So g of x is the 5. So we want less than or equal to. This time, the endpoints are included. That's why these are solid dots. All right, so we're going to go from -1 to 7. So x has to be between -1 and 7. And because this is less than or equal to, that means these have to be less than or equal to as well. All right, choose the words to correctly complete the statements. The x-coordinate of the points of intersection are included in the solutions of this. This is represented in the graph by closed circle. And again, that's because this is less than or equal to. That means the x-coordinates are part of the solution. They're included. All right, choose the functions and variables to complete the explanation of how you can use the graph to solve absolute value of x minus 3 plus 1 greater than 5. All right, find the points on the graph of f of x that are directly above the points on the graph of g of x. All right, so we're looking for greater than 5, so this one has to be above this one. So we want, when f of x is above g of x, that's when it's greater than. And then we know that the x values of those points are the solutions of the inequality. All right, so it says, use the graph of f of x equals absolute value of x plus 3 minus 2 shown to determine the following. Which equations and which inequalities have no solution? Select all that apply. All right, so if I add 2 to both sides, I get equals 0. If I add 2 here, I get negative 1. So if you remember, you can't have an absolute value that is negative. Absolute value equals something that's positive. So this equation, you always have to isolate the absolute value first to be able to figure out if it's true, but it can't have a negative number here. So if I add 2, that gives me negative 1. That would not be true. All right, and then the inequality, if I add 2 to both sides, I get 0. So this is less than 0. That's not going to be true because remember, absolute value is a V-shaped graph that's turned up, and it can't be less than 0 unless there's a negative sign in front of it. So if I do add 2 here, I get negative 1. So this is greater than negative 1. That would be true. So this says find the ones that have no solution. So the 2 in the middle should have no solution. And again, if you need to solve if you need to like get these numbers to the other side and then graph or sketch the graph and look at that to see if it's a true statement or not, that's a good way to do it. All right, for f of x equals absolute value of x plus 3 minus 2 and g of x equals c, where c is a constant, which of the statements are true? Select all that apply. All right, so the number of solutions of f of x equals g of x must be 0 or 2, depending on the value of c. All right, that's not going to be true because what if it hits at the vertex? What if this hits at the vertex of this? It would be one solution. So the number of solutions of f of x must be 0, 1, or 2, depending on c. So that one would be true. And let me sketch that out here so you can visually see that. If I can get my pen to work here. All right, so if you have absolute value function, it's saying you've got 2, 1, or 0 solutions. All right, so if I have an absolute value equation here, if I have a V-shaped graph and then the constant functions down here, there's no intersection points, so there would be 0 solutions. If I have a V-shaped graph and my constant function hits at the vertex, that's going to be one solution. Or if I have like what we looked at before, where it has a point here and here, then that represents 2 solutions. So that second one should be a correct answer because you could have no intersections, 1 intersection, or 2 intersections, and that would be your number of solutions there. All right, so the number of solutions of f of x is greater than g of x must be infinity regardless of the value of c. So the number of solutions where f of x is greater than g of x must be infinity. Okay, so that's true because your f of x is your absolute value function. So it's going to continue in the upward direction forever, regardless of where the constant function is. All right, so the number of solutions of f of x is greater than g of x could be 0 or infinity. All right, depending on the c value. All right, so f of x greater than g of x could be 0 or infinity. This one's not going to be true because it contradicts this one, and we already said that this one is true. All right, the number of solutions of f of x greater than or equal to g of x must be infinity, regardless of the value of c. So we can say that one is true as well. And then the number of